4, the product rule. So the product rule and quotient rule you're probably going to be singing by the end of the year in terms of you continually will be using this. This is where things get a little bit more complicated, but it's a pattern that you have to get good at. Okay, so for example, the product is first times derivative of the second, second times derivative of the first, added together. You're going to say that a million times in this class.
Say again.
First times derivative of the second plus second times derivative of the first. Obviously, it doesn't matter if you have the order switch as long as you have derivative of one plus the original, or times the original, plus derivative of the other times the original. But you're going to do that over and over and over. So in this section, we develop a formula for the derivative of the product of two functions. It's tempting to guess. Okay, so if you have f of x is x and g of x is x squared. So we know that x times x squared is x cubed, right? But if we do them separately, right? So if we do these separately, just like simply, what's the derivative of x? 1. What's the derivative of x squared? Well, that's not the right answer, right? Or is it? Is that the right answer or not? No. We just talked about this because we know that if we did this out, what's x times x squared? And what's the derivative of that? So something's wrong here. We just got two different things. We did them separately, and then we actually multiplied them and did it. What's that? So what they're saying is, right here, guys, notation, they're telling you this isn't true. The fg, the derivative of fg, is not f prime times fg, or g prime. Okay? That means the sum difference rule doesn't apply for multiplication. So we have to do the product rule. Okay? Does that make sense? So we cannot do derivatives piece by piece with product rule. That's why we have the product rule. Here is the product rule. So look, fg, the derivative of that, derivative first, or excuse me, first times derivative second plus second times derivative first. You can say however you want, but essentially it is 1 with the derivative, 1 without, 1 with the derivative, 1 without. Okay, added together. So like I said, you can say it a lot of different ways. I always say first derivative second plus second derivative first. Yeah. First derivative of the second plus second derivative of the first. And they're multiplied. So you can write it like this, guys, if you want. First d second plus second d first. When we do the quotient rule is going to be high d low plus low d high, all over low squared. You're going to say these. Yeah, you're going to say these. It's going to be crazy. Okay. Want to just do one? Sure. So first derivative of second plus second derivative of the first. First derivative of the second plus second derivative of the first. So in order to do this, that's why I did have it written out, guys. It's important that you have, listen please. It's important that you have all the, you can kind of do them separately like this and insert them. So there's my first derivative of my first, my second derivative of my second. You're going to have 4 different things that are in here. Okay, 4 different pieces. All right, so let's look at an example here. So this one, 2x cubed plus 5 times 3x squared minus x. If you're saying, well, can I FOIL it out and just do what we were doing earlier? Absolutely. But we're going to get the harder ones. You won't be able to do that. So we're going to practice the product rule with something easy. Okay, so you will do first times derivative of the second plus second times derivative of the first. Look at that. I'll write the notation underneath. Again, these are interchangeable because it's addition. So the one that I wrote down, I think, was second derivative. Oh, no, I wrote it that way. So first, d second, second, d first. Okay, questions? So now we're not done. We have to simplify it. Okay, so now we have to FOIL this out. Okay, so we're going to get 12x4 minus 2x cubed plus 30x minus 5 plus 18x4 minus 6x3. I get 30x4 minus 8x3 plus 30x minus 5. So this is the derivative of that function. We only have 3 total examples on these, so I'll be done here in a second. Any questions? That's a basic, easy setup there. Get a little bit more difficult as you get more complex with radicals and all that kind of stuff. That's where you'll start writing a novel with your problems. Okay. All right, so this one here, root x times 2 minus 3x. So maybe if you're really if you like to be really structured, here's an idea. You could do this. You can go, okay, my f of x is root x. My g of x is 2 minus 3x. My f prime of root x, we know this one, we've done it a few times now, is 1 over 2 root x. Okay, if you forgot that one, it's because this is x to the 1/2. Drop the 1/2, and you minus 1 to negative 1/2, so it moves to the bottom. G prime is negative 3. So, first, root x times derivative of the second, negative 3, plus second times derivative of the first. Okay, if we wanted to rationalize, okay, and try to keep everything separate, this is pretty good here. You could leave it here. It's okay with me for now, but I'm just going to do the book rationalize, so I'll rationalize here. Rationalize Math 20 as well. Like that. So, is there a way I could put these together as one fraction? Just times 2x at top and bottom, common denominator. So this is all just fraction work now. So the reason that helps is because I have like terms here. I have the negative 6x root x and the negative 3x root x, which is negative 9. Okay, can I write that negative 9x root x differently? It may be easier for us to deal with. Looks kind of ugly. How could you write that with exponents per se? One over 2 plus 1 though, because the x1, right? 3 over 2. So this is x to the 1, and that's the 1/2. So it's 1.5, which is 3 over 2. So this here, just kind of really just fully simplifying here, could be that plus that all over that. You could hit the x's, but I'll stop there. Okay? You could do the x's one more time, but I'll stop there. Okay? All right, one more example. Oh, sorry. Okay, we'll pause it. So the third one, now we add the tangent to it. Find the slope of the tangent to the graph of the function at the point 1,5. So it's at that point. That's different than from 2,9 when we struggled with last lesson. It's at the point 1,5, so we can plug this one in. So we find the derivative here, plug 1 in to get the slope at that spot, and then solve for our line. Okay, or does it say just slope? Nope, just a slope. We don't have to find the line, just a slope. So all we got to do, derivative, plug 1 in. That's all we have to do. Derivative, plug 1 in, that'll kick out the slope at that point. Okay? All right. Why don't you guys try this one? Let's try this one. I'll pause it, and then I'll do it here in about 3 minutes. Probably won't take it that long. Sorry. Oh, okay. So 3x squared plus 2, 6x squared plus 2x cubed minus 1, 6x. Okay. 18x4, 12x squared. So here's the equation of your tangent slope. That's your slope equation, essentially. You plug a 1 in, it tells you what the slope is at that point. So you got 30 plus 12 minus 6. 42, 36 is the slope at that point. Okay? All right.